morning, students. I am Krishna Rao, Assistant Professor in CSC Department. I am handling the compiler design subject. Today, we will discuss the YAAC compiler at another compiler. Here, we discussed what is a parser. The first phase of a compiler is lexical analyzer. The second phase of compiler is parser generator. The lexical analyzer will read the input character by character and generate a sequence of tokens. So, lex programs are the generate the lexical compiler which takes the input character by character and gives a sequence of the tokens. Here, the first phase lexical analyzer will send the sequence of tokens to the second phase of a compiler, that is a parser. The syntax analyzer or parser generator will take the sequence of tokens as input and it follows the syntax rules of programming language. It will follow the syntax rules of the programming language. So, for example, in C, every statement ending with semicolon. A binary operator should have two operands. So it follows the syntax rules of the programming language and it will group the list of sequence of tokens into the parse trees. That is the task of the syntax analyzer or parser. So here in this parser will generate the syntax as a messages, right? It will generate the syntax errors, right? So here these parsers will be constructed with the automatic tools like YAAC. YAAC at another compiler is an automatic tool that generates a parser program, right? So, parser takes a sequence of input tokens and gives a parsers, syntax trees or derivation trees, okay? These parser programs are generated automatically by using the YAAC compiler. At YAAC means at another compiler. Here, this is constructed with the bottom-up parsing technologies. Example, LAL1. So mostly we use LALR1 to generate this YAAC at another compiler which in turn generate the parser programs. So here this YAAC will take the syntax rules as an input and generate a parser program as an output. That parser program will take a sequence of input tokens and it will use a output of the parse trees, right? So at another compiler will take the input a syntax symbols context represented by context free grammars. The syntax rules are represented by context free grammars that will be the input to this at another compiler which generate the respective parser program. Which generate the respective parser program. This parser program will take a sequence of input tokens. It will take a sequence of input tokens and use the parse trees as syntax trees as the output. So the construction of LR parsers requires lot of work for parsing the input string. Hence, the process must involve automation to achieve efficiency in passing as an input. Right? So we use the LR parsers in the construction of the at another compiler. Here, the parser will in communication with a scanner. So scanner will generate some tokens that will be given to parser. It will construct the parse trees and it calls the scanner to generate some more tokens. So meanwhile, the scanner will construct some more tokens and will send to a parser. So that is a communication between a scanner and parser. So parser analyze the syntactic structure according to the grammars, right? So all the syntax structures of the programming language we represented with the context-free grammars, right? So we represented with the context-free grammars, right? Here, parser analyze the syntactic structure according to the finally, parser executes the semantic routines. YAAC is at another compiler. It is an LALR parser generator. It will generate LALR parser generator. So here we are using a the resultant parser will have a LALR bottom up parsing methodology in producing the parsers, right? So YAAC generates at another compiler generates a tables according to the grammar rules, driver routines in C programming language, y dot output a report file. So at another compiler will generate a tables according to the grammar rules. A table according to the grammar rules. And driver routines in C programming language and a y dot output is a report file. Y dot output is a report file. So here YYLex is a scanner lexical program. So at another compiler automatically invokes the lexical program. YYLex is a lexical program which generates y.tab.h file through the -d option. The lex input file must contain y.tab.h. For each token that lex recognized, a number is returned from YYLex function. So here a parser will invoke the lex program automatically, which gives its tokens with a respective number is returned. So YYLex is a function which returns a token with number. So the basically at another compiler is a LALR parser generator that reports conflicts or uncertainties if at all present in the form of error messages. So at another compiler will generate a LALR parser. So if it found any errors, if it is found any errors, it will generate the error messages. So it will convert the given syntax rules in the form of context-free grammars will be converted to bottom-up parsing method LLR parser. Right? So here this at another compiler input file consists three sections. Right? That another compiler will input file consists of three sections. One is definitions, another second section rules, third section user code. These three sections are separated by this symbol percentage, right? This percentage symbol is used to separate the sections in the file, right? There are three sections in the file: definition, rules, user code. So at another compiler, input file consists of three sections: definitions, rules, and user code. These sections are separated by two percentage symbols. Right? Here we represent that another compiler translator can be represented as in this diagram. First one, declaration section. Ordinary C declarations. Second, translation rules. It consists of the context-free grammars. Third one, supporting C functions. Third one, supporting C functions. So these are the three parts of at another compiler specification, right? So at another compiler will take its input file and generate a LALR parser generator. The resultant LALR parser generator will take a sequence of tokens and generate the parse trees, right? So the input of the at another compiler will have these three divisions. The first one is declaration section. The first one is declaration section. Second one is translation rule. Third one is supporting C functions. Right? Declaration section, translation rule, and supporting C functions. So these three parts will be represented in the input files of the YAAC specification, right? So the declare section might be normal ordinary C declarations. Translation rules are the context-free grammars which represent the syntax rules of the programming languages, right? This represent the syntax rules of programming languages. Then supporting C functions, right? Supporting C functions. So in this translation, if it is required any functions, C functions that are defined in the third part, that is supporting C functions. So translation rules will perform the conversion. In the conversion, it may call any user-defined functions. So that all such user-defined functions will be represented in the supporting C functions. So these are the three parts of the YAAC specification. So at another compiler specification file consists of three parts. So what is the first part? The declaration section, right? In this section, ordinary C declarations are inserted and grammar tokens are declared. The tokens should be declared between these two symbols. Right? Here the tokens should be declared between the percentage flower bracket and percentage closing flower bracket. Right? So first part in this YAAC specification file is declaration section. That is a declaration section. In this section, ordinary C declarations are inserted. Right? Ordinary C declarations are inserted and grammar tokens are declared. And grammar tokens are declared. The tokens should be declared between the percentile open flower bracket and percentile closing bracket. Right? So in the file, whatever it have, it will be defined. It's required, it will be defined in this declaration section. Okay. The second one is translation rule section. It includes the production rules of context-free grammar with corresponding actions. Right? The second part of the at another compiler input file is translation rule section. Here it will includes the production rules of the context-free grammars. It will includes the production rules of context-free grammar with corresponding actions. With corresponding actions. So here the specification of the file comprising these sections can be written as percentile, declaration section, then translation rule, all the required C functions. All required C functions. So the input file for the at another compiler will have these three. So first one is declaration section. This is defined between these two symbols. It is defined between these two symbols. Then it is followed by translation rule section. Then it is followed by translation rule section. Right? It is followed by translation rule section. Then it followed by a separator, two percentile symbols, followed by required C functions. These translation rules will have the context-free grammar productions followed by action part. In this action part, it may require any routines or functions. All such routines and functions are defined in this third part. So, the required C functions are defined in the third part. Right? So, these are the three divisions in the input file of the at another compiler which generate the LALR parser generator. Now, so we'll see an example for the at another compiler input file. Right? So first we are using the symbols. Right? These are the symbols. Definition section. The first part will consist the definition section. So include std.h. Include std.h. Right? Int flag equal to 0. int flag equal to 0. Right? Hash include html.h int flag equal to 0. So all the header files, all the variables, whatever the definitions we required, C declarations that we required will be added in this definition section. So add that are added in this declaration statement, right? Hash include html.h int flag equal to 0, right? So we'll have the end percentile closing curly bracket, and also all other declarations, token, number, left, addition, associativity, plus, minus, multiplication, division, and mod operators, and left parenthesis, right parenthesis. So all the declarations that we required, we define in this declaration part. So the first part is a declaration part in the input file of at another compiler. Now, second one is rules section. Here, this is a separator that we use between these three parts of the input file: declaration file, rules section, and support functions, right? The supported functions. All these will be separated by double percentile symbol, right? The rule section. Here, arithmetic expression E will result printf result percentage equal to $sign. So in the input, the calculated value is printed in the place of $, right? So the value of the $, is calculated from the below expressions, right? So here that arithmetic expression E, the arithmetic expression E will give a printf statement. The result is %d /n $sign return 0. $sign return 0. The $sign is a print replaced with a value. That value is calculated from the below respective expressions, right? The first one, that expression is addition of two expressions, right? Addition of two expressions. This is the addition of two expressions. So the resultant value will be the value of the first element added to value of the third element, and the resultant value used in the printf statement. The resultant value is used in the printf statement, right? So here the second expression is subtraction. The first expression is addition. The second expression is subtraction. So in this one, we using the value of the first element minus value of the third element. So value of the first element minus value of the third element will give the value that will be used in this printf statement. So the value of the first element minus value of the third element will result this one. Stored in this one, that will be replaced in the printf statement, the result. Then third expression is multiplication. The third expression is multiplication. The multiplication is resulting value equal to value of the first element multiplied with value of the third element. Value of the first element plus value of the third element. Right? Value of the first element multiplied with the value of the third element, that will be stored in this result that will be used in the printf statement. Right? The multiplication is value of the first one into value of the third one. Okay. The next one is division operator. The next one is a division operator. Right? The division operator is two dollar signs, that is a resultant value, first value divided by third value. The first value divided by the third value. The division value is stored in the double dollar sign that is used in the printf statement to print the result of the division. Right? So here this double dollar sign value is calculated from these expressions. Now, mod operator. The next one is mod operator. The mod operator is $1 mod operator with $3. $1 mod operator with a $3. Okay. Expression mod operator expression equal to $1 mod operator with $3. The resultant remainder will be printed in the printf statement. Right? The next one is parenthesis expression. Resultant value is once again the result of the expression. Right? The second element is expression. So that we are saying as the second element. The number equal to a value that is simply as a value of the first element. This is the action part it is given. The first one is an expression. Its respect to action part is defined here in the flower brackets. The flower brackets, whatever that represented is the action part. The result is printed in the printf statement. So, end of the expressions and the end of the rule section with once again these two mod operators, percentile operators. Right? The first one is declaration definition section. Second one is rule section. Here we will represent all the syntax expressions followed by its action part. So respectively, depending on the operator, we will perform the addition, a subtraction, multiplication, division, mod operator, and the result is printed in the printf statement. So this is the expression. It's with respect to action part. Right? Then third one. This third one will consist of all the user defined function whatever it required. So third one is a functions that we have used in the second section that are defined in this third one. Right? User defined functions. So C code, it may consist C code, void main, printf, enter any arithmetic expression which can have operations, addition, subtraction, multiplication, division, modulus and round brackets. Right? Here, YY parser is a function which generate the respective parsing method. Right? If flag is equal to 0, entered arithmetic expression is valid. Otherwise, simply it gives as invalid. So here the input file for the at another compiler will have three sections. It will have three sections. So first is definition sections. Normally whatever we required, we declare the C declarations. Then will second section, it's a rule section. It will consist of expressions followed by action part. It will consist expressions and it is followed by respect to action part. So the printf statement will print the result of addition, subtraction, multiplication, addition, mod operators. So in the third part, it will have the C code. All C functions which are required, the used in the second part, right? In the second section, we may call up any C code, C functions. All such C functions, C code will be defined in the third section, right? This is the example for third section. If there is any other such generated, so we uses this y other, it is a function. It will says as a entered arithmetic expression is invalid. So here that entered arithmetic expression is invalid, right? So here another example for the at another compiler program for infix calculator. So this is an example for infix calculator. So the first part of the input file will have the declarations, right? It will have all required declarations, right? So percentile, open and closing. So whatever the C declarations used in actions, we'll include that header file stdio.h into the our generated parser, right? So in the first part, definitions part, so we'll define the definition. So a union, int a number, start line, type, so and term, factor, number, digit, expression. So we are defining these words: digit, number, factor, term, expression, a number, type. So in the first division, in the first section, we are declaring the all the definitions. Now these three divisions will be separated by two percentile symbols. Then descriptions of expected inputs corresponding to actions in C. Here line is an expression ending with semicolon. Printf result is the result of expression. So for each in the rules section, there will be expressions. That expressions will associated with the some action part, right? So here expression semicolon will print as result is the result of the expression. Print the result of the expression. Then expression equal to term we are considering. Expression we are saying as a term, or expression plus term, or expression minus term, right? Here the result will be the addition of first element and third element. This is the first element, this is the third element, respect to expression and term. And the action part will have the subtraction of expression and term. Expression and term. $1, $3. Addition of two elements. Right? $1 plus $3. $1 minus $3. So according to that expression plus term will give this result that given as output. This represent action part respective for this expression. Then what is a term? It's simply a factor, right? It's simply a factor or a multiplication of term and factor. It's a multiplication of term and factor. So a multiplication of first element and third element. Multiplication of first element and the third element. Second one is division operator. Division operator is the first term divided with the factor. Term is divided with the factor. First element divided with the third element. The result is in the $2 value. Right? So term is simply a factor. Otherwise, it will be a multiplication of term and factor or division of term and factor. Now, what is a factor? Factor is a number. Factor is a number. Simply return the value of $1. Otherwise, it might be a recursive expression itself. It might be parenthesized expression. It might be parenthesized expression. So what is the expression? Is a second element. So $2. Right? So factor is a number itself. Otherwise, it might be a recursive parenthesized expression. So that is the value of the second element. What is a number? Number is a digit. Number might be digit. It simply return the value of the first element. Otherwise, it might be number followed by digit. A recursive expression. A number followed by digit. A recursive expression in the context-free grammars. A number followed by digit. In that case, value of the first term multiplied with the 10 added with the second value. Right? Value of the first element is multiplied with the 10 and added to the second element. So the number of times it is repeated, so the value is multiplied with 10 and added to the value of 2. So ones, tens, hundreds, thousands and so on. So depending on the number of digits. If it is a digit is a 0, it's written a value 0 itself. If it is a 1, it's written value 1. If it is 2, it returns value 2. If it is 3, return 3. So if it is a 4, return value 4. If it is a 5, return value 5. If it is a 6, so up to 9 and 0, depending on the input value, it will return corresponding 0 to 9 digits. Right? Then these are the rule section. This one is the rule section. This both slides. Right? This is a rule section consists the line, expression, term, factor, number and digits. We are defined with respect to action part. Then the third part. What is the third part? It is a C code. Whatever required in the translations, it uses in the rule section. All that functions we are defined here. So main function tell about the return parser function. Return of the parse function. Then YAAC return get character. It communicate with the lexical analyzer to get to receive the next tokens. If any error message occurs, simply generate the error message to the standard error. Means simply it gives to the F file which consists the description of the error message. So we are using fprintf. So that are stored in some file, right? So here start line means all input should match with line. List all possible types of values associated with the parts of the grammar and gives each field name. Here type gives the individual type of the values associated with each part of the grammar using the field names from the percent union declaration, right? These are the definitions we have used. These are the actions and seed declarations and code, right? So double dollar resulting value for any part of the grammar. Double dollar indicate the resulting value for any part of the grammar, right? Dollar one and dollar two or dollar three. These are the values from the subparts of the grammar. YY is a routine created by at another compiler from lists expected inputs and actions. Here, this routine called YY for all inputs. We are using getChar, which just read the characters from the input file. YY is routine called by our YY pass, which whenever it detects an error in its input, right? So these are the example input files for the at another compiler which generate the bottom up passing method LAL parser generator. This parser generator will take the syntax rules of the programming languages, input the sequence of tokens and gives the output a parse right? The input file have three sections: declarations, rule section, supporting functions section. These are the divisions of the input files for the at another compiler automatic parser generator, which results to the a bottom up parser generator. This parser will take a sequence of input tokens and generates the a parse trees or syntax trees. So with this one, I'm closing this section. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.